It's space weather! Looking at the sun in 193 angstroms. This is the wavelength you want for coronal hole viewing. As you can see, there's one about to face Earth and another one rolling in, which I think the magnetic connection is just about to happen according to the phi angle. We're going to talk about wavelengths in a minute. But first, let's look at the magnetic lines. Speaking of magnetism, yesterday the magnetometer never went as high as we expected. It went a little higher than the day before, but not as high as expected, and these fields in the southeastern limb are returning to a slightly more normal state despite having coronal holes to their north. Thank you, SDO. Now, let's talk about wavelengths. Why do we look at the sun in different wavelengths? To see different aspects. When you look with the naked eye, well, let's go back. Here's the electromagnetic spectrum. Now, the only part your eyes are able to see is this tiny band of visible light in between ultraviolet and infrared. As you go up the energy spectrum, you get smaller wavelengths. As you go to X-rays, gamma rays. As you go down the energy spectrum, you get to infrared, radio waves, microwaves, TV waves, radio waves, very low frequencies, extreme low frequencies. Why do we do it? Because the sun gives away various aspects of what it's doing. For instance, 5,800 angstroms is going to show you about 10,000 degrees. Fahrenheit, that is. That's the surface of the sun, the photosphere. Now, you want to look at extreme UV, then you got to use a 94 angstroms view. Links to all of these sites will be in the description. 1,700 angstroms shows the surface of the sun. 1,600 angstroms shows you the mixture between the photosphere and the transition region, so-called. 304 is light emitted from the chromosphere in the transition region. 171, which is probably our favorite one, which shows giant magnetic arcs known as coronal loops. Anyway, we'll leave the link in the description. Feel free to read through. Here's a great graphic showing you the different designations here. HMI, which stands for what does HMI stand for? Oh, the heliospheric magnetic imager, because we're using a magnetometer to create those images versus just different wavelengths of electromagnetic radiation. And then other images which use different data tied together, known as Advanced Imaging Assembly, AIA. And there's all your different wavelengths. Now, while Greece is still rocking, we've experienced a lull in earthquake activity over the last, say, 12 hours. Let's look at the last 8 hours. Greece is still getting hit with mid-4 magnitude earthquakes. Here's a 4.6 9 hours ago. Japan got a 5.1. Some big quakes in Alaska, 3 in the upper 4 range, all in the same hour. Greece got another 4.4. Okay, so here's in the Kamchatka region of Russia, we got a 4.5. And then a big lull for a few hours. Now we got a very deep quake in Russia there, a 4.3 at 467 kilometers depth. Probably an indication that there's going to be another one in that area. maybe of a 5 magnitude. So Russia should be on alert. That eastern portion of Russia near Kamchatka. Greece also got a 4.7. A rare 4.3 in South Africa. Another 4.5 in Greece. Another very deep quake in the Fiji Islands, which happens to be the antipode of Greece, the opposite side of the planet. Not going to get into the weeds on that. Let's look at the solar wind. BTBZ is pretty convergent right now. And you see we got a phi angle of 232. That's going to drop down to about 180 as the magnetic field of that coronal hole connects. Solar wind density very low, 3.34 protons per cubic centimeter. Wind speed slightly elevated now to 408. That's the old coronal hole wind stream. Take a look at solar ham. See our magnetometer. There's a little bit of activity up in this area. Nothing appearing to be anywhere close to a sunspot yet. Let's look at the LASCO C2 for our Nibiru image. Oops, that was the wrong one. Let's get the 48-hour GIF so we can see Nibiru. There you go. There's Nibiru in the foreground. See that? Just kidding, that's Venus. And the reason it's phasing the way it is because it's between the Earth and the Sun, which means it's showing us its dark side. If we were focused on that, it would look like a crescent. Now, look in this area. See that coronal mass ejection? That was from a couple days ago, and it's not going to hit Earth. Just as we stated a couple days ago. Now, let's look at the more close-up view. Get a better image of that coronal mass ejection. Here it goes. Kaboom! And let's look at the rest of the data on spaceweathernews.com. X-ray flux, still flatlined. There's your solar wind. There's a magnetometer. It didn't get quite as high as we expected yesterday, but it was a little higher than the day before. We're now at the bottom of the range, and we should be climbing. KP index is at 2. Nice, safe aspect of the range there. Now, we're experiencing the most significant electron flux drop-off we've had in a couple days. So keep an eye on that. It should be coming back up shortly. There's your F2 ionosphere layer. Congratulations to everybody that learned about what that is yesterday. Thanks again, subscribers. We appreciate all your support. Let's close things out looking at 171 angstroms. As a more active region is rising over the northeastern limb. Well, that was some failed drawing, wasn't it? Anyway, there you go. Thanks for watching. Please don't forget to like and subscribe the videos. More content daily. Production value will be going up. And last but not least, may the wind be at your back and the atherosclerosis absent from your veins.